Greetings. This is the presentation for the Honors Advanced Data Science IA2. The title of the research paper that we've chosen is Database NewSQL Performance Evaluation for Big Data in the Public Cloud. Publication JCC and BD. The year of publication was 2019, and the authors of the research paper are Maria Murazo, Pablo Gomez, Nelson Rodriguez, Diego Madel. Introduction. At present, databases are not only expected to be flexible enough to handle different variety of data formats, they are also expected to deliver extreme performance, as well as being able to scale and handle big data. According to an estimate, there is 2.5 quintillion bytes of data created each day, but that pace is accelerating with the growth of IoT. 90% of the data that exists in the world was generated in the last 2 years. Different types of data, as well as continuity in data availability, has become more important than ever, and data is expected to be available 24/7 and from everywhere. For many years, relational databases have been the leading model for data storage, retrieval, and management. However, due to increasing needs for scalability, performance, alternative systems have emerged, namely NewSQL technology. NewSQL is a class of modern relational database management systems, RDBMS for short, that provide the same scalable performance of NoSQL systems for online transaction processing, read-write workloads, while still maintaining the asset guarantees of a traditional database system. The objective of this research paper is to address the problem of storage, recovery, and analysis of large volumes of data using non-traditional databases. The rest of this paper is organized as follows. Section 2 explains the generalities of big data. Section 3 explains the related technology. And Section 4 addresses the generalities of the database administrators and in particular new SQL solutions. Finally, the developed tests, conclusions, and future works are explained. Literature survey. Big data is a term utilized to refer to the increase in the volume of data that are difficult to store, process, and analyze through traditional database technologies. Compared with traditional datasets, big data often includes masses of unstructured data that need more real time analysis. Cloud computing is a technology to perform massive scale and complex computing. It eliminates the need to maintain expensive computing hardware, dedicated space, and software. Big data is the objective of intensive computation operation and stresses the storage capacity of a cloud system. The main objective of cloud computing is to use huge computing and storage resources under concentrated management so as to provide big data applications with fine-grained computing capacity. The challenges that are faced while working with big data include data representation. Data representation refers to making the data more meaningful for computer analysis and user interpretation. However, an improper data representation will reduce the value of original data and may even obstruct effective data analysis. Analytical mechanism. The analytical mechanism of big data shall process masses of heterogeneous data within a limited time. However, traditional RDBMS systems are strictly designed with a lack of scalability and expandability, which could not meet the performance requirements. Expandability and scalability. The analytical system of big data must support present as well as future data sets. The analytical algorithm must be able to process expanding and more complex data sets. The traditional databases cannot deliver capacity on demand that application development might be hindered by all the work required to make the database scale. Characteristics of NewSQL include NewSQL provides feature SQL as the primary mechanism for application interaction. NewSQL also supports the same asset properties that a traditional RDBMS system would support. NewSQL controls a non-locking concurrency control mechanism, which is helpful for real-time read writes as they won't conflict. NewSQL database DB shards architecture providing much higher per node performance than available from traditional RDBMS solutions. NewSQL support a scale-out, parallel, shared nothing architecture capable of running on a large number of nodes without suffering bottlenecks. NewSQL systems are approximately 50 to 100 times faster than traditional OLTP RDBMS. There are many new SQL databases that are being used in the big data era for real-time web and big data applications. Every database is having a particular data format for storing its data. Hence, a customer faces the problem of selecting the appropriate new SQL database for its business reasons. For this reason, it has been decided to work with cloud computing as support architecture, more specifically GCP and the spanner as tool. GCP or Google Cloud Platform is a suite of cloud computing services that runs on the same infrastructure that Google contained in its Google data centers. Cloud Spanner is a scalable, globally distributed database designed, built, and deployed at Google. An abstraction of it would be that it is a database that shards data across many sets of Paxos state machines in data centers spread all over the world. Spanner automatically reshards the data across machines as the amount of data or the number of server changes, and it automatically migrates data across machines. Over to you, Ankur.
Methodology. In the present work, the performance comparison between a MySQL database and the Spanner database was performed, both working on the Google Cloud platform. The first data set used contains data from the SUACI, which is responsible for addressing the needs and claims of the residents of the CABA. The data set is organized by year. For this work, only the year 2018 has been taken, which has 8,95,000 records with the following fields: contacto, periodo, etc. The second data set used shows a register of the streets of the CABA where the name, meaning, and code of the streets are included among other data. So to perform the performance evaluation, 3 queries were defined below. In the case of MySQL database, the way used to measure time is to connect the proxy, Cloud SQL proxy provided by the GCP platform with the MySQL database 8 through the console, then connect the MySQL workbench client and subsequently execute the query and record the time. In the case of the Google Spanner database, the query is simply executed in the console provided by the tool and the time is recorded. Which is shown in the above figure. The figure 1 shows the query execution in MySQL results. So the average times obtained for both databases are analyzed below. These times are expressed in seconds. So the table 1 shows the times incurred in the insertion of the corresponding records. In table 2, the results of the execution of the 3 queries for 2,000, 10,000, and 20,000 records are shown. Each value is the result of the average of 5 executions of each query. In figure 3, the results shown in table 2 can be seen graphically. Execution with Spanner. As in the case of the MySQL database, previous to the execution of the consultations, it is necessary that the insertion of the records in the database is relied upon. Table 3 shows the times incurred in the insertion of the corresponding records. In table 4, the results of the executions of the 3 queries for 2,000, 10,000, and 20,000 records are shown. Each value is the result of the average of 5 executions of each query. And in figure 4, the result shown in table 4 can be seen graphically. MySQL versus Spanner. As seen from the tables, we can conclude that Spanner has better performance than MySQL when the workloads are high, but this efficiency decreases with the complexity of the queries when the complexity of the queries increases. On the other hand, table 5 summarizes the average times incurred by each manager in executing the queries. In this table, it can be seen that in all cases, Spanner has shorter execution time than the MySQL. However, for query 3, the query with the greatest complexity, because it contains a join, execution times are on average longer than the queries for 1 and 2. This leads us to the preliminary conclusion that Spanner has better performance than MySQL. Conclusion. NewSQL solutions aim to bring the relational data model into the world of NoSQL. Since there are a wide variety of databases available nowadays, a new customer wishing to switch from the traditional physically hosted database server design to using NewSQL on the cloud. As we have already seen from the tables and graphs in the results section, we can safely conclude that NewSQL has drastic performance improvements over traditional SQL databases with respect to the execution times. Future scope. The use of greater workload, which will be implemented by increasing records in the database and increasing complexity in queries. Comparing the different types of NewSQL databases amongst themselves in order to identify the individual use cases depending on the business requirements and the read-write execution times. So here are the references. Thank you.